In today's lesson, we're going to learn how to write equations of perpendicular lines. The process for writing equations of perpendicular lines is exactly the same as the process for writing equations of parallel lines. The difference is the slopes. So hopefully, as we learned in our investigation, slopes of perpendicular lines are opposite reciprocals. So the only thing that changes in our process is the slope that we write down when we identify our new slope. So we're going to start, these steps should look very familiar. We're going to determine the slope and the y-intercept of the given line. So our slope multiplied by our x is 1/2, and our y-intercept is 4. Our new slope, here's the one step that is different. The step is the same, but the process is different. The slope of perpendicular lines are opposites. So my given slope is positive, my new slope will be negative. And reciprocals, my given slope is 1/2. When I flip that, it becomes 2/1 or 2. And of course, my new y-intercept is what we need to figure out. Everything else is exactly the same process that we practiced with parallel lines. Substituting into our equation, we have to take our new slope this time because it is different from the given slope. Using the ordered pair, putting our -1 into the asylum, it becomes positive. Our -5 stays outside, stays negative. Simplifying for y, distributing my -2, and combining my like terms. Alright, so now we're going to graph both lines. This will be a visual check for us that the lines actually are perpendicular and we didn't make a mistake when we were writing the equation of our new line. And of course, it's good practice for remembering how to graph. So we'll start by graphing my new line. Our y-intercept is -7 and my slope is -2. So make sure when you graph a negative slope that your line is falling. Make sure your line matches the slope that you get. Graphing my given line, my y-intercept is 4, and my slope is positive 1/2, so my line needs to rise, or I can fall and go to the left. You want to make sure that you extend your line at least, I would like you to extend it for the whole graph, but at least extend it until those lines intersect, and you can kind of examine, do they look like they're forming a 90-degree angle? And in this case, it looks pretty close. All right, same process. We're going to figure out what our given slope and given y-intercept are. So our given slope is being multiplied by our x, -3/2. Our given y-intercept is what we're adding or subtracting. Determine your new slope. It's the opposite. My given slope is negative, so my new slope will be positive. And reciprocal, so we flip the fraction. 3/2 becomes 2/3. And of course, we're going to be solving for our new y-intercept. Setting up our equation. Substituting our new slope and our point. Putting -6 into the asylum, -4 goes outside, and we're going to solve for y. So distributing my 2/3, I'll show my steps here again. Distributing it to my 6. Remember, another thing that we can do is make it one big fraction. You can multiply 2 times 6 and divide by 3. In this case, the numbers aren't very big, that's still pretty doable. But you can also, what I would like you to get used to looking for is common factors in the numerator and the denominator. And in this case, 6 divided by 3 is 2. So we've got 2 times 2 is 4, divided by 1 is 4. So when we simplify, combining our like terms, we get y equals 2/3 x. So think for a second about what our new y-intercept is. Hopefully you came up with 0. We are not adding or subtracting anything. So we're going to start at the origin when we're graphing our line, and we have a slope of 2/3. So we're going to rise 2, run 3. And extend it both directions. We're not sure where our other line might cross it. So we want to make sure we use our whole graph. Hopefully you graphed yours a little more accurately than I just graphed mine. We'll graph our given equation. Y-intercept is -8. And our slope is -3/2. So make sure that your line falls. In this case, I really didn't have enough room to fall 3, so I'm just going to go up and to the left. And looking at my graphs, they look like they form a 90-degree angle and they're perpendicular to one another.